Welcome. The topic we'll be discussing in this lecture is protection. So under this topic, we'll be discussing the goals of protection, the principles of protection, the domain of protection, and how protection can be achieved by using a concept called access matrix. And finally, we'll be discussing the implementation of access matrix. So the objective of this topic is to discuss the goals and principles of protection in a computer system, and also how protection can be ensured through access matrix. What are the various privileges that can be added or removed in an access matrix, and how access matrix can be implemented in a computer system. That's what we'll be discussing. Okay. So before starting the session, let us try to understand what is meant by protection. A related term with protection is security. So in the next chapter, we'll be discussing about security. In this chapter, we are discussing about protection. So protection and security, does it mean the same thing or does it differs? Actually, it differs. So security is something, a broader aspect. Security means that security basically deals with ensuring safety from external threats. Security ensures safety from external threats, whereas protection ensures safety from internal threats. Protection ensures safety from internal threats. If you see a particular organization, say let us take our institute, ICFITech. Say there is a server in ICFITech. So only the users who are within ICFITech will be allowed to access the server. Somebody from outside, they will not be given the privilege to access that particular server. So it's a very straight cut point, right? So somebody with ifhindia.org can access that particular server. If somebody is having some other email ID or user ID like IIT Hyderabad.org or IIIT Hyderabad.org, they cannot access, okay, because they are outside the organization. So this safety mechanism is called as security. Okay. So security ensures that only the right users can access the resource. Only the right user can access the resource. Okay. So in this example, only the users with email ID ifhindia.org can access the resource. So that is what security ensures. Now what protection does? Protection will ensure that the users who are able to access the resource, what level of privilege they will have. Some user may have full access. Okay, some users may have a limited access. So that will be ensured by security. That will be ensured by protection. So protection will ensure different users has access, but what is their level of access? The access privilege level. Some user may have more privileges. They can perform, they can change somebody's rights, they can enable or disable devices, but some other user will have only limited access rights. They can only just view. Okay. Say for example, if you take the LMS, only the students who are registered in the institute can access the LMS. Okay. And the faculty members can also access, but faculty members will have higher privilege than the students. Okay. And the administrator of the LMS will have more privilege than the faculty and the students. Okay. So these are the access rights, right? So security ensures that somebody from outside the ifhindia.org cannot use the LMS, right? And also security ensures that the users with ifhindia.org will be able to access LMS. But protection ensures that out of the users, different users with ifhindia.org email ID, who will have different level of access. If some email ID belongs to a student, then he will have a very restricted access. If some email ID belongs to a faculty member, he'll have more access. He'll have a full access to his course alone. But for other things, he'll not have a full access. He'll have a restricted access. And the LMS administrator will have a complete access to the entire system. Okay. So this is what the job of the protection. So protection ensures safety internally. Okay, fine. So we can say that a computer is a collection of objects. Here objects can be a hardware or a software. For example, you can call a printer as an object, you can call a disk drive as an object, or you can call a file as an object. All these can be called as an object. And every object will have a unique name and it will have a well-defined set of operations. Operation in the sense what can be done on the object. If it is a file, you can perform a read operation or a write operation or execute operation. If it is a printer, you can perform a print operation, such things. Okay. So the problem of the protection is to ensure what in the sense is to ensure that the object is correctly accessed and only those users or process that are allowed to access are accessing the object. So that the protection feature should ensure. The protection feature should ensure that only the right user is accessing the object and and he is performing the right operation. Okay. For example, say printer is allowed to access only by a few set of users. Then whenever a print operation comes, the operating system should check is the request is coming from the right user or not, or a right process or not. If it is from the right process, then allow. Okay. And on printer, what operation you can do? Only you can perform print operation. You cannot perform a read operation. You cannot perform execute operation. So the operating system should also check whether the user or the process is performing the correct operation on the correct object. Right. So that is what the goal of the protection is. And the principles of protection. The entire principle of protection depends on a concept called principle of least privilege. The principle of least privilege says that a user should be given only just enough privileges to perform their task. You don't give extra privileges. Why? Why should not we give extra privileges? We should not give extra privileges because if there is some mishap happened, or if a user performs some job wrongly, or if some external factors influence the user and because of that something havoc happened, then the damage caused will be loss, and the damage caused will be more if the user is given extra privileges. Okay. But if the user is given only the least privileges, then even if user performs some wrong operation, the damage that will result will be comparatively less. So one of the core principle of protection is the principle of least privileges. This is to ensure the damage is limited, and and the and the and the privilege can be static or dynamic. Static in the sense when for a particular process the privilege will be fixed, like during the lifetime of the process it will perform only so and so task, it will perform only so and so operation on so and so object. It will not do anything beyond that. So like that, if it is fixed, then that is called as static privileges. In some cases the privileges will not be fixed, it will be dynamic. During the execution of the process, the privilege may change. Initially it may want to perform some operations on some object, whereas later it may want to perform some other operation on some other object. So in that case the privileges may change. So that is called as dynamic privileges. Okay. So dynamic privileges can be achieved either through domain switching or privilege escalation. Okay, domain switching we'll discuss sometimes later. Privilege escalation means, say a particular process is allowed to perform read operation on a particular file, but later the same process also want to perform a write operation. Then it should place a request to the operating system, and operating system should check, and if the user is a valid user, if the user is authorized user, then the privilege should be given. So then the privilege is escalated from read to write. Okay. Similarly, there is a related concept called need to know. It is whenever a particular process want to perform some operation on a particular object, why they want to perform that particular operation, that should be known to the operating system, so that the operating system can ensure the safety of the system. So these are the core principles of protection. Fine. So to ensure protection, we'll be using something called as a domain. So a domain is a collection of access rights. A domain is a set of access rights. So what is access rights? So to ensure protection, we use something called as domain. What is a domain? A domain is a set of access rights. And what is an access right? An access right is a collection of object name and right set. Okay. Access right is a collection of object name and the rights set. So object name refers some object. It can be a file or a printer or anything. Okay. So let us say an object OI, which refers to a file or a printer. And this right set represents what operations can be performed on this object by a given user. So it may include read, write, and execute, which means that a given user can perform read, write, and execute operation on this particular object OI. This OI can be a file or any other object. Okay. If it is only read, then it means that the user can perform only read operation. If it is only write, then it means the user can perform only write operation. So here you can see there is a domain D1 which three access rights. This domain D1 contains three access rights. What are they? O3, the first access right which says that the user can perform a read and write operation on the object O3, and the user can perform read and write operation on the object O1, and the user can perform execute operation on the object O2. And there is another domain D2. What it says, a given user can perform write operation on the object O2, and a given user can perform print operation on the object O4. Similarly, there is another domain D3 which says that a given user can perform print operation on the object O4, and a particular user can perform execute operation on the object O1, and the user can perform read operation on the object O3. Okay. Sometimes the same access rights can be used by multiple domains. So you can see here this access right where a print operation can be performed on the object O4 is being used by domain D3 and also domain D2. So a domain is a set of access rights. Okay, fine. And the access rights can be defined using an access matrix. And access matrix, in the access matrix, rows represents domains and columns represents objects. And each entry in the access matrix, access of I comma j, it represents the set of operation that a process executing in a particular domain I can perform on object j. Okay. So in an access matrix, rows represents domain and columns represents objects, and an entry in this matrix, which we can generally call as access of I comma j, which means that a set of operation that a process executing in domain I can invoke or perform on object j. So let us try to understand the concept of access matrix with this diagram. So in this diagram, these rows represents domains, various domains, whereas columns represents objects. So here there are four objects. F1, an object F1, which may be a file, and another object F2, which is also a file, and another object F3, which is also a file, and another object printer. It's a hardware device. Okay. So process PI, if it is executing on the domain D1, if the process PI is executing on the domain D1, then it can perform read operation on the object F1, and it can perform read operation on the object F3. It cannot perform any operation on F2, and it cannot perform any operation on the printer. So this is the privilege for the process executing on the domain D1. If the process PI is executing on the domain D2, then it can perform only print operation on the object printer. It cannot perform any other operation. If the process PI is executing on the domain D3, then it can perform read operation on the object F2 and execute operation on the object F3. It cannot perform any other operation. If the process PI is executing on the domain D4, then it can perform read and write operation on the object F1 and read and write operation on the object F3 and no other operations. Okay. So this is how the access, the different access levels or access rights of different process on different domains can be represented through an access matrix. Okay, this is a simple access matrix. This access matrix can be refined to further levels. For example, the domain itself can be an object. The domain itself can be represented as an object also. So generally we discussed that the rows represents domain and the column represents objects. So here you can see this F1 is an object which is a file, F2 is an object which is a file, F3 is an object which is a file, and this laser printer is an object which is a hardware device, And then these four are domains, but these are represented here as objects. So D1 is represented as an object, and D2 is represented as an object. D3 is represented as an object, and D4 is also represented as an object. So what does it mean here? So here we are introducing a new privilege which is called a switch. It is called a switch. So here you can see the with respect to domain D1 and D2, the switch privilege is enabled. That is for D1 and D2, with from D1 to D2, from the domain D1 to D2, the switch privilege is enabled. It means that a particular process which is executing in domain D2 can switch to a particular process which is executing in domain D1 can switch to domain D2. Okay, a particular process, say a particular process PI, which is currently executing in the domain D1. So this switch privilege, what it says in the sense, the user PI or the process PI which is executing in the domain D1 can switch to the domain D2. Right? And the other operations are as usual. The process PI which is executing on the domain D1 can perform read operation on the object F1 and perform read operation on the object F3. Apart from this, it can also perform a switch operation to the domain D2. Similarly, the process executing on the domain D2 can perform print operation on the laser printer, and it can switch, and this process which is executing on the domain D2 can switch either to the domain D3 or to the domain D4. The process executing in the domain D3 can perform read operation on F2 and execute operation on F3. It cannot perform switch operation to any other domains. The process executing on D4 can perform read and write operation on F1 and read and write operation on F3, and it can switch to D1. That is, the user or the process which is executing on domain D4 can switch to the domain D1, right? That is, if the user who is executing on domain D4, if they want to switch to D2, then how they will do? They can first switch to D1, and from D1 then they can switch to D2. Okay. So this is what the switch privilege does. So switch privilege is basically used by one domain to switch over to another domain, right? Similarly, there is something called as copy rights. That is a right to copy. So right to copy is represented using the star symbol. So here you can see there are two star symbols. So what does it mean? Let us take this example. Say a process PI, which is currently executing on the domain D1, is currently executing on the domain D1. What it means in the sense, the process PI can perform execute operation on the object F1, and it can't perform any operation on F2, and it can perform write operation on F3. But write is added with a star. What does this star means? Star means that this particular process which is executing on the domain D1 has the right to copy this access to any other domains also. It has the right to copy this access to any other domains also. That is if the process executing on domain D1 want to allow D2 to perform write operation on F3, he can copy the write to D2. Similarly, if he want to allow D3 to perform write operation on F3, then also he can allow that. Same that this read also applicable. If the process PI is executing on the domain D2, then it can perform read operation on F2. Apart from that, it has the copyright that it can copy the read operation to any other domains. If this particular user or the process which is currently executing on the domain D2 would like to allow D1 to perform read operation on F2, then he can copy this read here. Similarly, if he want to allow D3 to perform read operation on F2, then he can copy the read to here. Okay. So that this diagram has resulted, this diagram B, this table B is a resultant of table A. So here you can see previously the read is only here, read star, but here you can see there is a read comes here. How it came? Because the process which is executing on D2 has the right to copy the read to any other domains. So this particular process which is executing on D2 has copied the read to the domain D3, right? Okay. But here you can see this star is not coming here, which means that D3 is only can read. D3 don't have the right to copy. D3 don't have the right to copy this read to any other domains. That right is remains only with D2. So this is called as copyrights, access matrix with copyrights. Fine. The next concept what we'll be discussing is access matrix with owner rights. If a process which is executing on a particular domain has a owner right, if a process executing on a particular domain has a owner right, then that particular process can add or remove any privileges. Then that particular process can add or remove any privileges to any domains respective to that particular object. Okay. If a particular process PI has an owner privilege on a particular object, then that particular process can add or remove any privileges to any domains for the respective object. Okay. So what does that mean? Let us try to understand with an example. So here, let us say that there is a process PI which is currently executing on the domain D1. So this process PI has owner right on the object F1, and also it can perform execute operation on F1. It don't has any, it can't perform any operation on F2, and it can perform write operation on F3. If the process is executing on domain D2, then it can't perform any operation on F1, but it can perform read operation on F2, and also it has copyrights for read operation, and also it's the owner of F2. That is, owner means the owner can add or remove any privileges for any of the domains with respect to that particular object. And the domain D2 also can perform read operation on F3, and it has the copyright on read operation, and also it's the owner of F3, and also it can perform write operation on F3. So again, owner means the owner can add or remove any privileges to any of the domains for that particular object. Okay. If the particular process, if the process is executing on the domain D3, then it can perform only execute operation on F1. It can't perform any operation on F2, and it can't perform any operation on F3. Okay. Now let us see how this diagram how this table has become like this. So if you just to see the difference between these two tables, here you can see one write is added. Okay. Similarly, here you can see one write star is added, and here you can see one write is added. How it was added? How it was added? So this was added because when the process PI is executing on the domain D2, when the process PI is executing on the domain D2, what happens? It has owner privilege on F2. As it has owner privilege, it can add or remove any, any privileges to any of the domains for that particular object. So it has added a write privilege for itself. It has added a write privilege on F2 for itself, and also it has added a copyright write privilege, right? And that copyright write privilege is copied to the domain D3. So it means that now D3 can also perform write operation on F2. Similarly, when the process PI is executing on domain D2, it has ownership on the object F3. It has ownership on the object F3. So the owner can add or remove any privileges. So here the owner is adding write privilege to the domain D3 for the object F3. So this is how the table was transformed, something like this. Okay, fine. So similarly, there is another privilege which is called as control. Which is called as control. So how it? So basically, let us see this particular diagram with domains as object. So here a control is also added. Here a control is also added. That is for D2 and D4. There is a control is added. So what does it mean? It means that D2 can control the domain D4. So it means that the domain D2 can control the domain D4 because the control privilege was added to D2 comma D4. Okay. So it means that the domain D2 can control the domain D4. So what does it mean by control? Control means the domain D2 can remove any privileges that are associated with the domain D4. So domain D4 has these privileges. It can perform read or write operation on F2, read and write operation on F3, and switch operation to D1. Now, if D2 want to remove any of these privileges, D2 can remove. Okay. D2 can also add privileges if D2 is the owner of some privilege. Okay. And that is how this diagram is converted, something like this. Here, previously you can see here, D4 has read and write operation on F1 and F3. But here you can see it has only write operation. The read operation was removed because D2 has control over D4 and D2 wanted D4 to remove D1. D2 wanted D4 to remove the read operation on F1 and F3, right? So these are the different types of access matrix. Okay, this is how the protection can be represented through access matrix. Okay, fine. Now let us try to understand how these domains can be implemented. There is one of the way to implement domains, which is used in multi system. The multi system implement domain in this way. How it implements in the sense it represents each domains using a concentric circle. It represents each domains using a concentric circle where the innermost domain has the full access. The innermost domain can access the entire system. There is nothing which it cannot access. It can access the entire thing. The next innermost ring, it can access almost everything except the innermost ring, except the zeroth ring. So from if the user is in the zeroth ring, the zeroth ring represents domain 0. Okay. From domain 0, you can access the entire system. From domain 1, you can access the entire system except domain 0. Okay. Similarly, from domain 2, sorry, similarly from domain 2, you can access uh, see this is domain 2. Okay, from domain 2 you can access the entire system except domain 0 and domain 1. From domain 3 you can access the rest of the system except domain 0, 1 and 2. Okay, from domain n minus 1 you can access only the domain n, only the last domain you can access. You cannot access anything else, right? So let there is two domains di and dj. Okay, and let us say that j is less than l. Let us say that j is less than l. Okay, if j is less than l, then it means that di is a subset of dj. What does it mean? So let us say this particular domain, zeroth domain. So this is di. So here I is nothing but uh, here I is nothing but 0. Here I is nothing but 0. Okay. Say the next domain. This is dj. Let us say this is dj. Here j is nothing but 1. Here j is nothing but 1. Okay. J is nothing but 1. Okay. And if j less than I, if j is less than I, okay. So or let us say this is j. Say this is j and this is I. This is j, this is I. So if j is less than I, so dj represents zeroth domain and di represents first domain. If j is less than I, then what does it mean? di is a subset of dj. Okay, please understand. di is a subset of dj. It means that domain 1 is a subset of domain 0. Okay, domain 1 is a subset of domain 0 because from domain 0 you can access everything, whereas from domain 1 you can access everything except domain 0. Okay, so domain 0 is a subset of uh, domain 1 is a subset of domain 0. Okay, domain 1 is a subset of domain 0, right? So the domains are represented using the circular concentric circles in case of multi system. And one of the drawback is it's a complex method to represent, uh, and so it is not a basic way of representing, and there are more overheads involved in this type of representation. So it is not a commonly used practice to use this method of representing. Okay. Then let us see how the access matrix can be implemented. There are basically two ways to implement the access matrix. The first method is to use a global table. So there will be a table. You will maintain a global table across the system, and in this table, each row will have these things: domain, object, and write set. So in each row, you'll have something called as domain, which is DI, and object, which is OJ, and then access rights. That is a process which is executing on domain DI can perform these operations on the object OJ. What are the operations that will be represented through access rights? Whether he can perform read, write, or execute, or print, or what, everything will be performed. Okay. So like that, for every domain you should maintain, it should every domain you should maintain a record. Not only for every domain and for every object, this record should be maintained. Okay. So the drawback with this technique is the table which you are going to maintain, the global table, might be too large. It may not fit into the memory. Okay. So that is one of the drawback with this type of representation. The another type of representation is to use an access matrix. That is, you just use the access matrix as it is. So here we discuss the access matrix. No, just represent the access matrix as a matrix, as a sparse matrix. A sparse matrix is something where most of the entries are unfilled. Here you can see most of the entries in this matrix are unfilled, which means that from the particular domain you cannot perform a particular operation on so and so object. Okay, so we can just represent it using a matrix itself, where where each cell can be represented as domains and write set. Okay, so in the each cell we can mention for a particular domain what operation can be performed, whether read or write, or both operations. That is the row will represent the domain and column will represent the object, and you can fill up the cells like what you can want to perform. That is the same whatever the access rights matrix we have discussed, as it is we can implement, right? So that's it about this particular topic. So here we have discussed what is meant by protection, how protection differs from security, what are the principles of protection, what is the principle of least privilege, and what are the different ways of achieving protection through access rights, and how to implement, what are the different ways of achieving protection through access matrix, and how to implement access matrix. So these are the things we have discussed. Fine, let us stop here. Thank you.